Hi, this is Marwa, and this is our fifth video about polynomial functions. We are going to discuss in this video the conjugate root theorem, which is a theorem about roots of the polynomial function. We discussed the rational root theorem in our last video, and in this video we're going to see what will happen if the root is not a rational root. Now, as we have discussed before, that rational roots are roots that can be written in the form of a over b, like as we said, -3 over 1, 5 over 2, half, and so on. These are rational roots. Now, we said that there are other types of roots, which are irrational roots. Now, irrational roots, like radicals, can be written in the form of a plus radical b. An example for that would be 2 plus radical 3. This is an irrational root. Radical 5. This is an irrational root. The number under the square root is not a perfect square, so your answer for that cannot be an integer or a whole number. So these are irrational roots. There are other types of roots which are complex roots. Complex roots are the roots that can be written in the form of a plus bi. Like what? Like something as 2 plus 3i or 2i. These are called complex roots. These are called irrational roots. And the rational roots we have discussed in our last video. You can take a look back at it. I will put it for you in a card here so that you can check. Now, the conjugate root theorem, what is that about? The conjugate root theorem discussed two things. It discussed the irrational roots and the complex roots. What does it say? It simply says that in case you have a root for a polynomial function that has rational coefficients. Rational coefficients means a polynomial functions with coefficient like, let's say, 2x cubed plus 3x squared plus 5x plus 2. These coefficients like 2, 3, 5, and 2, all of these are rational numbers. So for any polynomial function that has rational coefficients, like we discussed here, if that polynomial function has an irrational root or a complex root, then its conjugate is also a root. What do we mean by that? Now, we have here 2 plus radical 3. If 2 plus radical 3 is a root for any function, polynomial function, then its conjugate, and I believe we discussed what conjugates are, its conjugate, which is 2 minus radical 3, is also a root. If I have radical 5 as a root for a polynomial function, its conjugate, negative radical 5, is also a root. We can't have a root as a radical 5 alone, and when we multiply we get rational coefficients. That's not possible. It has to be radical 5 and its conjugate, negative radical 5. Same situation for complex roots. If I have a complex root like 2 plus 3i and the polynomial function has rational coefficients, then this is not the only root. Its conjugate, 2 minus 3i, is also a root. Same, if I have 2i here, its conjugate, negative 2i, has to be a root as well for the same function. Now let's take in mind that when we say conjugate, we switch the sign only for the radical part, but not for the real part. Sorry, for the radical part, not for the rational part. Same here. Only for the imaginary part, not for the 2. So 2 stays positive, you switch the sign for positive 3i becomes negative 3i. And if it was negative, it becomes positive. One more time, what do I mean by the conjugate root theorem? It states that if I have an irrational root or a complex root for a given polynomial function with rational coefficients, its conjugate has to be a root as well. Okay, now let's answer the question we have here to get a better understanding of the concept. Now this question says, this question states that a quartic polynomial, quartic means it's of the fourth degree. A quartic polynomial p of x has rational coefficients, and we discussed what is that. If radical 2 and 1 plus I are roots of p of x equals 0. What are the other two roots? We said radical I cannot be alone a root. Its conjugate, which is negative radical 2, has also to be a root. 1 plus I cannot be an only root. Its conjugate, 1 minus I, has to be a root as well. So if I see that a polynomial function with rational coefficients has a root of radical 2, I know for a fact its conjugate, negative radical 2, is also a root, even if it's not given. If I know that 1 plus I, which is an imaginary or a complex number, is a root, then I know for a fact that its conjugate, 1 minus I, is also a root. Now let's look at another type of questions that you can get discussing this theorem, conjugate root theorem. This is a multiple choice question. Says that what is the third degree polynomial function? Third degree polynomial function means I have three roots. Y equal p of x with rational coefficients, so that p of x is equal to 0, has roots negative 4 and 2i. Only two roots are given. Now negative 4 is a rational root. We have nothing to do with that. But 2i is a complex number. This is an imaginary root. If I know that 2i is a root for the polynomial function, I know for a fact that its conjugate, negative 2i, is also a root. So which one of these? Let's work it out. I know now for a fact that the zeros or the roots, and both have the same meaning, we discussed that multiple times, of the function I want to find are negative 4, 2i, and negative 2i. If I want to find the equation, I will change these zeros or these roots into linear factors. So x plus 4 multiplied by x minus 2i multiplied by x plus 2i. Now, when I multiply, I'm going to use distributive property. You can multiply x plus 4 by x minus 2i, but it's going to be a very long multiplication procedure. An easier way to do this is to multiply the conjugates first, like multiply x minus 2i by x plus 2i first, and when you find the answer, then multiply by x plus 4. So let's use distributive property and multiply these. Now x plus 4, I'm not going to multiply that now, I'm just going to leave it, then I'll use distributive property to multiply these. X times x, that's an x square. Then x times 2i, this is plus 2ix. Negative 2i times x, that's a negative 2ix. And negative 2i multiplied by positive 2i, this is negative 4i squared. Now x plus 4 is the same, and let's simplify this before we move further. Now 2ix minus 2ix, these are opposite to each other, they'll be cancelled because they'll give me a 0. X squared will stay, so I have x squared here, and negative 4 multiplied by I squared has a value of negative 1, so negative 4 multiplied by negative 1 is positive 4. I will end up with two binomials that I can multiply together very easily. X squared multiplied by x is x cubed, then plus 4x squared, then plus 4x, and plus 16. This is the polynomial function they are looking for. This is p of x, which is equal to x cubed plus 4x squared plus 4x plus 16. And if I try to find the zeros for this polynomial function, I will find that they are negative 4, 2i, and negative 2i. I hope this has been helpful for you. Conjugate root theorem states that if you have an irrational root or you have a complex root for a polynomial function with rational coefficients, then the conjugate of these roots are also roots for the same polynomial function. In our next video, we'll be discussing the fundamental theorem of algebra, which will show us how to find all types of roots, regardless they are rational, irrational, or complex, for any polynomial function. I hope this has been helpful for you and gives you a better understanding on how to find equations for polynomial functions with complex roots. Thank you for watching.